Welcome back to Industrial Problem Solving. My name is Dave Roysum. In this first of two short segments, we carefully and completely define the problem we are working on. Don't skip this step because you think it is obvious, because it seldom is. Don't skip this step because your boss or customer has already defined the problem for you. If you assume that they've defined the problem completely or even correctly, you may well find that you will get tripped up before you even get started. In statistics, we have type 1 and type 2 errors. Type 1 is to believe something is false when it is in fact true. Type 2 is to believe something is true when it is in fact false. In this section, we will try and avoid the most common problem-solving error called a type 0 error. That is, to work on the wrong problem. At the root of all problems are people. People are not happy with something. You need to know who these people are by title, if not by first and last name. There's quite a difference if your customer's operator, or their purchasing agent, or their plant manager, or all three are unhappy. In the first case of the customer's operator being unhappy, you may have some time to figure things out. In the last case, where everyone is unhappy, it may already be too late. Next, you need to find out what these people are unhappy about. This is far more specific than words coming down from on high can ever possibly safely convey. As we will see in the case of customer complaints, there is no safe way to know what they are unhappy about short of going to their plant and talking to their operators. Next, you need to find out when the problem began. That is not the same thing as knowing when you got the complaint. In many problems in your plant, the problems actually began when the product was first conceived, and perhaps even before the machine was built. In other words, since day one. Finally, you need to find out what part of what machine the problem first appears. Remedies may be found there, or found upstream, or found downstream of that spot, but that is where we will begin our problem-solving investigation. There are several conventional ways that we might define the problem. It could be verbal, pictorial, numerical, or based on a target specification, or some combinations. We will expand on this topic quite a bit more as we go through the course, but this will serve as a placeholder for now. However, we must be super careful about words. Let me share with you a story. There was a supplier to Mexico for tissue. The Mexican tissue customer was complaining about low basis weight. The supplier paid the claims and thought no further of it. This, we will see later in the course, was a big mistake. A month later, they got a complaint from the same Mexican customer who complained about, again, the same defect, low basis weight. This time, the customer service rep did a little more checking. They checked the roll ID and went to the lab test results for that particular roll, and the basis weight was within spec, so they paid the claim. Again, as we will see, a big mistake. Finally, another month later, the customer complained yet again about low basis weight. This time, the customer service rep said, "Why don't you send me a sample of this and we'll send it to our lab?" So a while later, the customer service rep got the envelope with the sample in it, opened it up, and there was a hole in the sample. This wasn't just low basis weight. This was no basis weight at all. You might think that this problem was one of a customer who may not have had a good command of English. Yet, it is my experience that the problems of communication are far worse when people speak the same language because they assume they know what the other is saying. For example, the word telescope can refer to any one of 5 totally different defects. Worse yet, the word telescope has equivalent aliases that include scoping, coning, shooting, dishing, and others. Another example from my work is the word COF. While the word is most commonly taken to mean a laboratory friction test, I had one customer who also used the same word for failure to bond, with the presumption that there was a connection between bond and the friction test. As a final example for extreme caution, I will share briefly the story of a job assignment I had in Canada. The assignment was to increase machine speeds by 10% to keep up with new orders. Yet, upon further inspection, I learned that the machine was down 20% of the time due to web breaks and down another 10% of the time due to machine breakdowns. To speed up a machine is trivial. You just turn the knob. Yet, to do so on a machine as fragile as this would only decrease productivity. To improve productivity, we would need to at least improve maintenance and quite possibly redesign parts of the machine. Doing either should improve productivity. Doing both may allow a safe speed increase that might actually improve productivity. If you think of these as just isolated cases of management getting the problem definitions wrong, think again. It is much more common you think, and perhaps even the norm. In fact, seldom is there a single definition for any problem. Often, there may be 3 totally different goals. What they say it is, what they want, and what is needed. Of course, the they is what we started with in slide 2 of this segment. Let me give you an example from home that I'm sure many of you can relate to. My wife frequently said, "You are always working on your stupid," and you can fill in the blank. In my case, it was an experimental airplane. While I did not ignore my wife any more than most husbands, that was not really the issue. What the real issue was that experimental aircraft is dangerous, and she did not approve. In hindsight, she was right, because after 3 years of flying, I had an engine failure at night over a city, and my airplane was totaled in the crash. I have a segment in my Life of an Engineer series if you're curious as to the details. Let's wrap up this segment by reiterating how important it is to always begin the problem definition in human terms, at least in your head. An early success story of using a human rather than a technical solution happened about 1 century ago. Customers were complaining about the slow elevator in a high-rise building. An architect did a cost study and found that putting a faster or second elevator would cost more than the building was worth. The workaround is found on nearly every elevator today. That is, a mirror and pretty surroundings, so that you have something to look at while you're waiting. Of course, now we have smartphones to occupy spare minutes. Another example includes the most massive computer recall in history that could have been dealt with by a simple thank you for pointing out a 1 in 10 million error for a random number generator function that is almost never used. Instead, Intel suffered a $1.5 billion loss due to their ham-handed handling of a common technical issue of a tiny design flaw. Finally, we have the ubiquitous and often quite incorrect assumption that a technical QA test specification may have anything to do with limiting customer dissatisfaction. Thank you so very much for joining me for Industrial Problem Solving. In the next segment, we will take a deeper dive into getting the problem definition right by talking about a favorite topic for business, and that is money. Stay tuned.